Dear students, now we are entering into the uh, problems for practice session. Here we are going to solve some of the problems which is related to the things that we have studied in the previous uh, videos. That is stress, strain, deformation, Hooke's law, elastic constants, Poisson's ratio. By using the relationship between elastic constants, we are going to solve some of the basic problems in the topics. Before get into the problems, we must know the basic unit conversion. These are the things. This is the very basics, but oftenly students will may make mistakes while solving the problem because of lack of awareness how to calculate the how to convert the uh, units from one unit to another unit, like in dimensions as well as in load. So we must know about centimeter to millimeter, millimeter to centimeter, millimeter to meter, centimeter to meter, meter to millimeter, these things. So this is the table which will give the basic informations about the unit conversion. And also we must know about load, unit of load, Newton, kilonewton, meganewton, giganewton. So easily we can remember that kilo, mega, giga, tera, something like that. So 10 power 3, 3, 6, 9, 12. So here we are maximum we'll use kilonewton, meganewton, giganewton only. So kilonewton, 1 kilonewton, 10 power 3 Newton, 1 meganewton, 10 power 6, 1 giganewton, 10 power 9 Newton. And some of the problems they may use megapascal. So all must know about megapascal to Newton by millimeter square unit conversion. 1 megapascal equal to 1 Newton by millimeter square. So this is the first basic problem. A steel rod of 30 millimeter diameter is subjected to a tensile force of 20 kilonewton. Find the stress induced in the steel rod. So as already we have discussed in the topic stress, stress is defined as the force of resistance offered by the body against deformation. That is force of resistance per unit area offered by the body against deformation. That is stress equal to load by area. Here the load is tensile force. The value is 20 kilonewton and the diameter is given 30 millimeter. From the diameter we can able to find the area. So load by area will give the value of stress. This is a very simple problem. You can solve on your own. This is the second problem. A brass rod of 30 millimeter diameter and 1 meter long is subjected to a tensile force of 20 kilonewton. The extension of the rod is 0.0025 millimeter. Find the strain produced in the rod and modulus of elasticity. So this is the continuation to the previous problem. The previous problem we have studied, we have calculated stress. Now we are going to calculate the strain as well as modulus of elasticity. So strain is nothing but it is the ratio between change in length to the original length. Since the tensile force is acting, the deformation will be a extension, that is elongation. So change in length is given in the problem 0.0025 millimeter and the original length is 1 meter. Here the twist. So actual length is given in 1 meter, change in length is given in millimeter. So we have to convert the actual length into millimeter, that is 1 meter equal to 1000 millimeter. So you can easily find out the value of strain, and From the previous problem, we have already studied, we have calculated stress. So modulus of elasticity means stress by strain. Hope you are all understand this concept. I think so. So this is the third problem. A copper tube of 25 millimeter internal diameter and 40 millimeter external diameter with a length of 1.25 meter is subjected to a compressive force of 50 kilonewton. Identify the nature of the deformation and also find the elastic constants. Take the change in length as 0.65 millimeter and Poisson's ratio as 0.23. So previous two problems we have solved for solid sections, solid steel rods. Here we are going to solve about hollow sections. So this is the diagram. So internal diameter and external diameter both are given in the problem, that is 25 millimeter internal diameter and 40 millimeter external diameter. The length also given 1.25 meter. We have to convert it into millimeter, and here the nature of force is compressive force. The value is 50 kilonewton. We have to convert it into Newton, 50 into 10 power 3 Newton. The first question is identify the nature of the deformation. So since the force is compressive, the nature is decreasing length. Decrease in length. And also find the elastic constants. So elastic constants means modulus of elasticity, modulus of rigidity, bulk modulus. So in this slide, we have given the relationship between elastic constants. Once we find the value of modulus of elasticity, we can easily find the other two elastic constants by using Poisson's ratio. So modulus of elasticity means here the force is compressive force. It's the ratio between compressive stress to the compressive strain. So stress equal to load by area. Area for hollow section we can easily find out, and force given 50 into 10 power 3 Newton. So we can easily find out the stress, and also actual length is given and change in length also given. Strain is equal to change in length by original length. From that we can easily find out the value of strain. So by using stress and strain we can find the value of modulus of elasticity, that is capital E. So Poisson's ratio is given. So directly we can find the other two elastic constant, that is modulus of rigidity and bulk modulus. So hope you all understand the basic problems. Thank you.